So for video number 4 for section 2.2, let me draw the following motivating picture here, and we'll discuss it. So suppose I have a function, and it's not going to be defined at 1, let's say, and suppose it looks like this, where that is 2 and that is 5. So here's f of x. So taking a look at this function, we can ask, what's the limit as x goes to 1 of f of x? Well, one guess might be that we might say that, well, as x if x is a little bit bigger than 1, and we're moving to the left, then our values for f of x seem to get closer and closer to 5. And so we might say that, we might want to say the limit of, as x goes to 1 of f of x is equal to 5. But if we went in the other direction and we took numbers that are a little bit less than 1, f of x would be a little bit less than 2, and so we might say the limit of f of x is equal to 2. And so this is a very undesirable situation. We can't say that it's the limit is equal to 5. We can't say the limit is equal to 2 because there's no single value that we want to say that there's only a single value for the limit. And so we can't say that just because x is really close to 1, that we're really close to 5 or really close to 2, because that depends on whether we're a little bit bigger than 1 or a little bit less than 1. And so we're in a situation here where the limit as x goes to 1 of f of x does not exist. And so maybe you would say, okay, we throw up our hands and we're done here. But as it turns out, we do want to be able to say something useful that says, as we are a little bit bigger than 1 and we're moving towards 1 from the right, as we're going in this direction, that the output value is close to 5, gets closer and closer to 5. And we want to be able to say that if we're a little bit less than 1 and our input value is getting closer and closer to 1 from the left, our output value is getting closer and closer to 2. And so this ends up meaning that we want to define what are called one-sided limits. So previously, what we were doing was called two-sided limits. So everything that we did before, the previous handful of videos, those are all two-sided limits. Now we can just discuss this new twist, which are one-sided limits. And so how one-sided limits look like are going to be, well, so I'll just introduce it with an example. The example we've drawn up here. The limit as x goes to 1 of f of x, and we want this to be from the right. And so to indicate that we're coming from the right, we put in a little plus sign. So this is the limit from the right, or we could say the right-hand limit. Or limit as x goes to 1 from the left. We said that's getting closer and closer to 2. And so to indicate that we're getting closer and closer from the left, we put 1 with a little superscript minus sign here. And so that's our left-hand limit. Let's just work out an example with an actual function here to illustrate this concept. So let's say that our function, f of x, is absolute value of x over x. So realize that this is defined for all values of x other than 0, because at 0 we get 0 or 0, and that's bad. If x is positive, if x is positive, this just reduces, the absolute value of x is x, so let's just reduce this down to x over x is 1. If x is negative, this absolute value x is negative x, and this reduces down to minus 1. And so, pictorially, graphically, this is the function it looks like. Here is 1, here is minus 1, here is f of x. And so it does not take too much creativity to see here that the limit as x goes to 0 from the right, that's with a plus sign of f of x, is equal to 1. Limit as x goes to 0 from the left of f of x, so coming in here, that's equal to minus 1. And so the overall limit of f of x, let me pull out the red marker here, does not exist. So that's an example that we can do here. And just to wrap this up, I'll just note here that saying that the limit as x goes to c of f of x is equal to L is equivalent to asserting that the two one-sided limits, limit as x goes to c from the right, right comes with a plus sign, and limit as x goes to c from the left, that comes with a minus sign, that these both exist, and these both are the same thing. Those have to be the same numbers here. So if I tell you that an overall two-sided limit exists, that the limit as x goes to 7 and f of x is equal to 6, well, that would tell me the limit as x goes to 7 from the right of f of x is equal to 6, and the limit as x goes to 6 from the left of f of x is equal to 6. So this statement is equivalent to asserting both of these. Even if both of the one-sided limits exist, if they aren't equal, you don't have the overall limit. That's the example that we just saw. So that's an introduction to one-sided limits.